Okay, question 2. Again, I'm going to use the same strategy that I used on the last question, right? Okay, I'm going to write down what the question tells me, right? So at the top of the jump, okay, the whale's velocity is 0 meters per second, right? So writing that down in symbols, u is the initial velocity of the whale, and that's 0 meters per second. It tells me how far it falls, 2.2 meters, so that's the displacement, right? 2.2 meters. Okay, from the top of the jump to the surface of the sea. And then it says calculate the velocity. So that's my question mark. Now, there's one thing that it doesn't tell me, but I do know. It doesn't explicitly tell me the acceleration, but I do know the acceleration because this is happening on Earth. All right, and you can see there, look, where necessary, assume that the acceleration of free fall is 10 meters per second squared, right? So we know what the acceleration is already. Okay, this is 10 meters per second squared. Okay, so now I'm looking for a formula that links U and S and A and V, and hopefully you know the formula is V squared equals U squared plus 2AS. Okay, then it's reasonably straightforward to do the substitution. Okay, 2 times by 10 times by 2.2. Okay, if you tap all of that into a calculator, okay, you should get that V squared is equal to 44. But we're not quite finished yet, of course, because we've got to take the square root of that. Okay, now it depends on your calculator. My calculator's just told me that that's 2 root 11. Okay, but actually for a physics exam, they want you to give it as a decimal, right? Okay, and the decimal that it gives me on my calculator is 6.633, blah, 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 right? Now, how many significant figures do we give our answer to? Again, same as we said in the first question. Okay, and we're going to look at the input data for this question. It's given us that to 2 significant figures, so we're going to give our answer to 2 significant figures. So the best answer that we can give here is 6.6 meters per second. Okay, the resultant force causes the whale to slow when it is. The resultant force is this much, right? So again, use the same strategy. Resultant force is sigma F. Okay, so that's 18,000 newtons. Mass of the whale, okay, 4,100 kilograms. Okay, and then it's asking me to calculate the acceleration, so that's my unknown. All right, I know a formula that links these things together. Okay, and the formula is sigma F equals ma. But it's not asking me for sigma F, it's asking for A, so I need to make that the subject of my formula. Now, if I'm not confident at rearranging, then of course I can use the formula triangle, like this. Okay, and then I'm going to cover up A with my thumb, and that's going to tell me what the formula is. It's sigma F over M, which is 18,000 over 4,100. Oops, 4,100. And again, I'm going to type that into my calculator. Okay, and again, the calculator is giving me a fraction. I don't want it as a fraction. I want to give it as a decimal. So I push the SD button on the kind of middle right of the calculator. Okay, and that tells me that the acceleration is 4.3902, blah, 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 blah. Again, look back at the question, right? You can see, look there, there's 2 significant figures, okay, for this, and there's 2 significant figures for this one. So we're going to give our answer to 2 significant figures. So the best possible answer is that the acceleration is 4.4 meters per second squared. And that's it for question 2.